Alright, let's finish up Chapter 8, the retake test. So let's take a look at 17. Here's triangle ABC. Well, let's mark it. First of all, I've drawn this kind of to scale. It doesn't have to be exactly to scale, but angle B is 105 degrees, so that's your obtuse angle. So I would definitely call that angle B. Angle A is 46. I made that to try to look like about 46 degrees, so that's angle A. And then the other angle, obviously, would be C. What else do they tell you? They tell you the two angles, 46 degrees. Let's put it in here. This obtuse is 105 degrees. They tell you side C. Now, if this is angle C, side C has to be right here, and that's 19.8. Alright, so now we take a look at this, and it just says find A to the nearest tenth. So what is A? If this is angle A, then this is side A, and that's what we're looking for. So let's see how we're going to do this. I've got this angle, looking for this side, and I know this side, but I don't know this angle. But since they gave me two angles, I can actually solve for this pretty easy. Don't have to do any trig or anything. So I just go 105. I'm sorry. I'm putting in the calculator as I speak. I'm going 180 minus 105 minus 46. And that gives me a grand total of 29. So angle C right here is 29 degrees. So I know this angle now. Look what I've got. I've got an angle, I've got a side opposite the angle, and I have an angle up here, angle C, and I have a side opposite that angle. So I have 3 of 4 things, and if I have 3 of 4 things that I need to find, I can use the law of sines. Since I'm solving for A, I'm going to put that on top. So I'm going to put A over the sine of angle A. Well, I happen to know angle A is 46 degrees. Now, let's do the same thing with the other two the side and the angle that I know. So the side is 19.8 divided by the sine of the angle that's opposite that, which is 29 degrees. And now, by putting the A on top, I can solve for A kind of easy. I can just multiply both sides by the sine of 46, so it's going to be sine of 46 right here. That goes, see what I did? I multiplied both sides, it just goes away here and it goes on top up there. Now, I just plug all this stuff into a calculator. Okay, so I threw it onto the calculator and I get 29, whoops, I'll start that over again. It's kind of ugly. 29, 0.37, let's go 0.4, let's round it to the 10th. Oh, it does, it says it right here also, round it to the nearest 10th. So 29.37 rounds to 29.4, that's all they ask for, is side A, right there, and I'm finished. That's what side A is equal to, 29.4. Okay, let's look at number 18. Kind of the same deal. We have to draw a triangle ourselves. The way I started was they told you angle N was 108, so I drew an angle that looked kind of close to 108. See, that's 90. That's a little bit more, so it's about 108, I guess. Good enough for us. And since that's the 108, I'm going to call that side or angle N. And they say this is triangle LMN. So if that's an N, this could be L. Actually, let's do it the other way because I made this one a little bit longer. That's side M. So if this is side M, which is 61, and this is side L, which is 42, then this would be angle L, and this would be angle M. Because the side, the lowercase letter is always opposite the uppercase of the same letter. And we've talked about that before. So now look what we have. I've got an angle in between these two sides when we have a situation like that, and it says find side N, which would be this side right here. This is set up perfectly for you to use the law of cosines. Let's jot down the law of cosines. That would be, now I know we don't have A, B, or C here, but the sides still correspond the same way. So C squared equals A squared plus B squared. The way I taught you to remember this is this looks just like Pythagorean Theorem, but we're not finished. We need to add a few things to it. So watch, we're going to put minus 2AB cosine angle C. Don't forget the 2. I just graded an Algebra 2 test, and somebody got almost every problem right on the whole final. I think they missed 2, and one of them they forgot to put the 2 here. So make sure you put that. Alright, there's the law of cosines. Let me box that in there. Let's see how that works out here. This is basically your A and your B, and this is your C. This is your angle C. So you just replace stuff in here. So we'll call it n, so it's n squared. The A and B are the other two sides, so we square them and add them up. So it's 42 squared plus 61 squared minus 2 times those two sides again, 42 and 61, times the cosine of the angle that's opposite this side. We're solving for side n. The angle opposite is 108, so it's the cosine of 108 degrees. Now it's just a matter of plugging all that into your calculator. Let me give you a little hint here. Let's even put this in a different color. Look at this right here. I'm going to put parentheses around all this. Okay, so in your calculator, go 42 squared plus 61 squared minus. Put a parentheses there on your own. Your calculator won't give that to you. See, it's in red. So put that in there on your own, then go 2 times 42 times 61, cosine 108, close the parentheses. Depends on what calculator you use. Whatever you get for an answer for that, then you're going to take the square root. So don't forget to take the square root. You practice it. Okay, I'm not going to go through it. We've talked about that plenty in class, but you need to practice and make sure that you get the right answer. So let's plug everything in. Give me a second. Plug everything in, and then we'll write the answer down. Alright, I threw that all in the calculator. Made sure you take the square root to get n by itself, and I got 84.07, and we'll just make it 84. Oh, kept it in red, didn't I? 84.1. Alright, we'll put that right here. And in this problem, that's all they ask for. They just say solve for n. We just did, and that's all we have to do for that one. Let's move on. We're almost finished. Alright, let's check out the last two. Says here's a vector wz, and so we're going to plot those points, negative 2, 2. So negative 2, positive 2, right there. And then we're going to plot 3, 1. 1, 2, 3, and then 1 right there. Now, let's connect them right to there. That looks good. Okay, it's a little small. Let's make this a little bit bigger. Alright, that looks a little bit better. Let's plot, or let's name them. That's W. This is Z. So your vector goes from here. This is where it starts, and it ends right here. I'm going to put an arrow because it goes in that direction. Starts from W and goes to Z. That's very important because it's vector WZ. Find the magnitude of the vector. When to find the magnitude means the length of it, how long that vector is. Well, we can do a couple things. You could do distance formula if you wanted to. You know what I'm going to do on this? I'm just going to draw it out as a right triangle. Watch. I'm going to drop that down. I'm going to take this across like this. Alright, and let's just count. Remember where we are. We're 2 here and we're 1 here, so from here to here is just 1. If I count from here to here, I was at negative 2 and I went all the way to 3, so how far is that? Well, that's 5. You can just do Pythagorean Theorem. So let's do that real quick. It's just 1 squared plus 5 squared equals, we'll call D for distance. That's 25, that's 1, that's 26. We'll do it real quick. So the distance is the square root of 26. So that length right there is the square root of 26. That's your distance. You could throw it in a calculator if you wanted to, I guess. But I would just leave it like that if I were you. Find the direction of the vector. Okay, this part is the part that's a little trickier. Find the vector, the direction. It goes here and it goes down like this. Now, if you remember, let's make this a different color. I'm going to make a new X and Y axis. Actually, I'm going to get rid of that, put it in a better spot right there. Okay, and let's see, let's just extend this out a little bit. Alright, there's the x-axis. Let's make a y-axis and just kind of, well, that wasn't very accurate, but you get the basic idea. If I was just drawing this by hand, it would probably be even worse. Let's just scooch this over to where it should be. Okay, it's not right on the negative 2, but it should be. You get the idea. So what we're trying to do here is we are trying to find the angle that it makes with the x-axis. This is my new positive x-axis right here. And then what I want to do is find that angle right there. Okay? So let's do it real quick. If I wanted to find this angle, you know what I did? I should have dropped it up here. But anyway, Oh, I screwed this up. But that's okay. You can still see. Watch. This angle and this angle would still be the same thing because they're alternate interior angles. So let's just find this angle right here. So what do we have? We got opposite. It's a right triangle. So we have opposite and adjacent. So we're going to use the tangent. So I'm going to go the tangent of the angle, which I don't know, is the opposite over the adjacent. So what we're going to do is put that into a calculator, and we're going to solve for theta. So you have to do the second function, so you hit 1 over 5, then second function tangent, depending on which calculator you use, and you'll get 11 degrees. So this angle right here is 11 degrees, so that must mean this angle is 11 degrees. Now, if you look at the answer on the test, I actually gave the positive. I would accept either one. I would say the direction is negative 11 degrees, or you could go 360 minus 11, which is 349. So either one of these would be acceptable for your direction of that vector. Alright, that's chapter 8. We're all done.